Today's lesson is going to be on graphing rational functions using transformations. So to review, a rational function is a function that can be written in the form p of x over q of x, where p of x and q of x are polynomial functions. Graphing rational functions is going to have a new feature called asymptotes. And these are dashed lines used to shape graphs. And when graphing rational functions, these are not crossed. So moving along and looking at the parent function, hopefully you guys recognize it's a fraction and we have something like 1 over x. And if you guys recall, with fractions, the denominator cannot ever equal 0. So our excluded value is going to be 0, or x cannot be 0. Now this hopefully leads into what our domain is going to be. Our domain is going to be everything but 0. So we'll have from negative infinity until 0, and then from 0 to infinity. Now if you notice in our domain, we have parentheses. These parentheses exclude 0, and that's it. Everything else is included. Now for the range, I think it's helpful to look at the graph. So if you look at the graph on the right, it extends all the way down, it extends all the way up. But in the middle, it does not cross the x-axis. So our range is everything except for 0 as well. Now to better understand what creates our graph, I think it's helpful to actually look at a table of values. So the first number I'm going to plug in is 2. And because our function is 1 over x, that gives us a half. So if I come up here to the graph, I can plot a point at 2 1/2. If I plug in 1, this one gives us 1 over 1, which is obviously equal to 1, and that gives us a second point. If I plug in 1/2, this one is a little bit harder to see, but you're going to have 1 over 1/2, and if you guys remember from complex fractions, that's the same as 1 divided by 1/2, which is the same thing as 1 times 2, the reciprocal of 1/2, otherwise known as 2. So if I look at my graph, that's where about 1/2 is. And if I come up here to the curve, there will be a point. And if you look at these 3 points, they create a curve. Now if you notice, we cannot plug in 0 to our graph. And the graph can actually also be shaped by this line that we don't see here, which I'm now going to put in. This is a vertical asymptote. The equation for this vertical asymptote is going to be x equals 0. I can also put in a horizontal asymptote right here. So this line shapes the graph even though it's not actually part of the curve itself. The equation for the horizontal asymptote is y equals 0. Now to help people remember when it's an x equals versus a y equals, I'm going to look at the letters. V, A, X. And H, A, Y. So you will be expected to remember when it's an x equals and when it's going to be a y equals. Now, considering the graph and looking at it, hopefully you guys recognize that there is no x-intercept and there is no y-intercept. Now we're also going to determine when our graph is increasing or decreasing. So I'm going to follow this path of the curve from left to right, and I want you to think about it. Is it increasing or decreasing? Hopefully you guys can see that from the x value of negative infinity to the x value of 0, it is decreasing. Now I'm going to look at the second branch. As I go from left to right, is the curve increasing or decreasing? Hopefully you guys recognize that again, that from left to right, from the x value of 0 to the x value of infinity, it is going to be decreasing as well. And yes, I know 0 is not part of the curve, but that's another reason for using the parentheses. Nowhere is it increasing though. So now we're going to consider the end behavior. And the end behavior is about what happens in the extremes. So as x approaches positive infinity means as we go to the right. So I'm going to trace my curve, and as my curve extends to the right, what is the y value that we're getting closer and closer to? Hopefully you guys are seeing that it's approaching 0. Now as x approaches negative infinity, that means as I go to the left, I'm going to trace the curve again. What is this y value that I'm getting closer and closer to, or approaching? I'm approaching the y value of, again, 0. So now moving along to graphing with transformations. This is the form that you're going to be seeing when you graph your rational functions. So you want to be able to look at this equation and identify the key pieces of information. So your vertical asymptote and your horizontal asymptote. So remember, it's VAX. So hopefully you can recognize that because this is right here with the x, this is going to give us our horizontal asymptote. So x equals h is the horizontal asymptote. This number sticking out here, that's all about the y's. So your horizontal asymptote is going to be a y equals k. Now, hopefully you guys remember from graphing transformations of other functions that the a gives us the vertical stretch. The h is the horizontal shift, so it's all about moving your graph left or right. The k is the vertical shift, and this moves your graph up or down. Now to actually graph the rational functions, we're going to do them in 3 steps. The first one is to graph the asymptotes. So remember H-A-Y, hey, and remember V-A-X, or VAX. Second thing we're going to do is plot 1 point per branch. And, or I should say, or 2 points for a stretch. They cost more. Third thing is we're going to extend branches towards the asymptotes. And this will make more sense when we start graphing them. All right, please continue with the next video to actually graph rational functions.